What a year to listen and learn about exciting research and world-changing technology. We zoomed into 2024 with the Clean Energy Initiative, Project Z. We prepared for a rare total eclipse. We discussed SwRI instruments launching to Jupiter's icy moon Europa, and so much more. Now, a review of the tech topics that inspired and intrigued us in 2024. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. From deep sea to deep space, we develop solutions to benefit humankind. Transcript and photos for this episode and all episodes are available at podcast.swri.org. Share the podcast and hit that subscribe button on your favorite podcast platform. Hello and welcome to Technology Today. I'm Lisa Peña. Did you listen and learn with us in 2024? We're rewinding the audio, taking you through the year and remembering those tech topics that got us talking. 2024 brought us conversations on Project Z, cybersecurity for vehicles, a total eclipse, a new hydrogen engine, a journey to Jupiter's moon Europa, and more. So let's get started, taking it back to episode 63 in January. Project Z is exploring clean energy technologies on the SwRI campus. The Z stands for Zero Emissions. SwRI researchers are evaluating the Institute's energy demand across 2 million square feet of offices, labs, and facilities, and using the data to develop and test clean technologies. Project manager and SwRI engineer Josh Schmidt told us about the timeline to zero. Okay, a lot of tools here being studied. So you mentioned solar, battery, thermal-based, carbon capture, hydrogen, so many things to look at. What phase is the research in now? Am I going to be recording this podcast with zero emissions soon? Will this be a zero emissions podcast at some point?
Yeah, I wish.
Soon.
The road to zero emissions is going to be kind of a long one. I mean, people have got these goals for 2035 and 2050. The current work right now, like I said, is to do our first engineering study of solar being installed for campus. And so if you want to say not that you're a zero emission podcast, but a 50% emission podcast, we may actually be there fairly soon.
I like that.
In the next few years. The full zero, part of our strategy is to be an R&D house. So some of these technologies that aren't ready yet, we're going to be proving out. So getting to full zero is a little dependent on our own skill, right? Like how good are we at bringing these technologies into a reality? So that's kind of an open question. I mean, we'd hope to try to meet some of these timelines that the big organizations and governments are putting out, like 2050. I think that would be great. But yeah, hopefully we can keep things rolling.
Yeah. So I record here on campus. So however the campus is powered is how the podcast is powered. So that'll be neat to see where we're at in a few years or down the road. Project Z continues to explore clean energy solutions for the SwRI campus, analyzing solar, hydrogen, carbon capture, battery, thermal energy storage, electricity generating systems, and adding wind and geothermal power in 2024. From zero emissions to the zero trust architecture for automotive networks. Episode 64 in February brought us an eye-opening conversation on cybersecurity for vehicles. The architecture shifts principles proven to safeguard computers and phones to vehicle electronics, software, and sensors. Project leader and SwRI engineer Maggie Shipman explained why vehicles are at risk for cyber attacks.
So all that to say, yes, cars are getting hacked. It might not be something you're seeing in the the civilian front, but we definitely are seeing a large range of hacks as folks who are tracking this in the industry.
So, at your suggestion to prepare for this episode, I did watch that Wired 2015 hack, and it is slightly terrifying. They're on the highway, and someone else is controlling their speed, their brakes. At first, it starts off innocent enough with a loud radio and windshield wipers, and it's comical, but it quickly becomes dangerous. So, this is definitely something that all drivers should consider at some point as our vehicles get more and more advanced. So let's talk about that a little bit. What makes modern vehicles especially vulnerable?
Sure. So when we think about it, right, vehicles are increasingly becoming connected to environments that are external to what you imagine when you think, oh, my car. So we're looking at remote connections, they're now connected through Wi-Fi, you've got connection through telematics communications, and even just plugging in your phone to CarPlay. We now have kind of entered the era of incredible technology, and we're taking advantage of some really neat features that we've actually created more threat vectors and a richer surface of attack.
So it's definitely great that our cars can do more, but with that, we need to ramp up that security. As Shipman explained in episode 64, zero trust refers to the concept of having zero trust in or not trusting any piece of a network until each asset is proven secure. March brought us a preview of a total eclipse over Texas and other parts of the U.S. SwRI's home city of San Antonio and surrounding areas were in the path of totality. Planetary scientist Dr. Tracy Becker told us what we could expect for the April 8th show in the sky.
So I have not actually been in the path of totality for an eclipse.
And I think that brings home how rare this is. Our in-house planetary scientist has not seen this in person, a total eclipse. So again, if you're in the area, you need to look up, and with safety in mind, of course, and get a glimpse of that and experience it, because it's such a rare thing to be able to witness. So you have seen total eclipses on video or in pictures. So what can spectators expect during the eclipse?
Yeah, so what we will experience in the path of totality is, again, that sort of sudden change from day to night. And this is truly one of the times where 99.99% is not round up to 100. If you are not in the path of totality, 100% in the path of totality, you will not experience the day to night transition that will happen. But for those of us in the path of totality, we will suddenly experience like what feels like evening and then complete darkness pretty rapidly. And again, the birds will they should be reacting. The insects might start chirping. There might be a temperature drop depending on where you are. And you'll just suddenly be in darkness for 4 minutes if you're in that center line. And from what I'm told, this is life-changing for some people. Some people will become eclipse chasers for the rest of their lives after experiencing one of these. And so it might be that kind of a movement for you, or it might just be something that you remember for the rest of your life as just a really cool, weird, bizarre experience.
The April total eclipse over San Antonio was certainly memorable. We did get cloud cover, but had some brief moments of eclipse visibility, and I will never forget experiencing that sudden day-to-night transition Becker described. The birds cleared the skies and the street lights came on in the middle of the day. Really such a cool moment to witness. In April, episode 66 took us to an earthquake zone in Turkey. SwRI senior research engineer Dr. Kristen Ulmer told us about her experience joining a research mission to uncover evidence and information in the aftermath of a deadly magnitude 7.8 quake. Timing was everything.
I got an email saying, we're putting the team together. It was a Monday. Can you leave this weekend? Right?
Oh, wow.
So I responded, yep. And fortunately, management here at Southwest Research Institute helped me quickly get ready to go.
So there was no time to waste. You wanted to get there soon after the earthquakes happened. So what was the goal for traveling there to gather data at that time? Why was it so important to be there right after those earthquakes?
After an earthquake, there are all sorts of ways that the earth responds, different ways that the ground moves, deforms, cracks, the way that buildings then respond to that same change in the earth. And those things can change quickly thereafter, right? There's a lot of cleanup. There's a lot of changing in weather that can wash away certain effects that we need to see in the soil. So it's important for us to get there quickly. And particularly for these sort of earthquake events, it's not something we can necessarily recreate in the lab. In the lab, we can look at a small scale or relatively small scale, but you can't necessarily recreate what you see out there in the field, where you have these gigantic tectonic plates moving and you have entire countries totally changed in the landscape. So it's really important for us to go out and quickly gather that information so that we can advance our understanding of earthquakes.
Ulmer says research in earthquake zones informs foundation design and engineering. The data can lead to improved building practices and codes and ultimately save lives. On to episode 67. In May, we discussed SwRI's new Space Robotics Center, where engineers are transforming Earth-based robotics into technology that operates in space. Engineer and program manager Mira Day Towler and research engineer Lily Bay Wallace described the role of robots in space. All right, so robots in space are not new, but SwRI is bringing these new capabilities. So why are robots needed in space? What are they used for?
When deciding to deploy automation in an application, roboticists often refer to the 3Ds. Is this application dull, dirty, or dangerous for humans to do? And when it comes to doing just about anything in space, it is incredibly risky and expensive for humans to do it. Humans need to be kept safe and kept fed, and also it's incredibly heavy to ship food and water. Robots do not need this food, water. What they need is power and insulation from the really harsh environment from space. And we can provide that with the power that's already provided for the satellites or the shuttle systems that are in space. The robotics currently in space perform some servicing tasks as driven by a human, either on board or, as we mentioned before, with a remote set plan. They are often collecting scientific samples and data for us to better understand the universe outside of our planet. We've been putting satellites into orbit around the Earth since the 50s, and now our atmosphere is full of satellites that are and also aren't used regularly. Immediate concerns and prime candidates for automation is the capability to service, fix, or perhaps decommission these satellites completely autonomously.
Yeah, that you mentioned something that falls into the category of ISAM, in-space servicing, assembly, and manufacturing. ISAM generally accommodates some of those things like recycling satellites, refueling, taking old satellites and throwing them back down into Earth to burn up. That's a huge area of interest right now because certain orbits are becoming really crowded. We think of space as being this enormous place, right? But within certain orbits that are highly used, and with the proliferation of launch, there's more and more going up into certain orbits, and that's causing a lot of problems and crowding in certain places. So a great example of robotics in space is for ISAM and for helping kind of clean up that orbit and those orbits that are getting crowded.
We need to create some more space in space.
Exactly.
Yeah. The Space Robotics Center is a test bed for robotics, autonomous systems, and machine vision in space. SwRI is shifting expertise in off-road autonomy, perception, robotics, and simulation to space applications. In June, on episode 68, we heard about the new H2ICE demonstration vehicle. SwRI engineers and the H2ICE consortium developed a hydrogen engine for heavy-duty vehicles, which could be a high-impact solution to curb harmful emissions. Consortium program manager Ryan Williams explained why they are tackling decarbonization in the heavy-duty space. All right, so you're building this vehicle, and you started with a heavy-duty Class 8 engine. So why start with the heavy-duty engine and not, like, let's say, a smaller passenger vehicle engine?
Yeah, that's a great question. The reason we started with the heavy-duty vehicle is because, like I mentioned before, there are some applications that are just going to be hard to decarbonize. Battery or our traditional passenger cars are smaller and lighter weight, and so it's maybe easier to get a battery into a car and make it run on electricity. But the problem is once you try to scale that up to the size of a Class 8 truck, the batteries get very large and very expensive and very heavy. So you can add about 20,000 pounds to your vehicle before you add the payload. And so with trucking and transportation in general, it'll be very difficult to apply that solution all the way across the industry. And so we're looking for alternatives, particularly in that heavy-duty space, because it's so energy intensive. We need alternatives to batteries in that space.
So is the thought that if you tackle the big vehicles first, maybe some of that technology could trickle down to the smaller vehicles easier?
No, our thought is really that it's going to take a little bit of everything to decarbonize transportation. There's no one silver bullet that is going to be the perfect solution for every application. And so we need to develop these technologies and then see where they fit, rather than the approach that's been taken in a lot of the world is to mandate the technologies and make it fit into every application.
You can learn more about the H2ICE consortium and vehicle at h2-ice.swri.org. That's h2-ice.swri.org. SwRI is designing, building, and operating the QuickSounder satellite, a collaborative mission between NASA and NOAA. QuickSounder will provide weather data on a fast production timeline with a low construction cost. On episode 69 in July, program manager Keith Smith and lead systems engineer Steve Thompson explained why a fast production timeline is key to the mission.
How are you getting the cost down, and how are you developing this on a quicker time scale?
So we're leaning into components that have developed or been developed in the commercial sector of space over the last decade, often referred to as new space. These are components that are developed with constellation models in mind, where attrition is allowable and risk is acceptable, as long as it's understood and they try to quantify it. So what we're doing is we're working with NASA to go from extremely high reliability point designs to components that are developed with the idea of replacement in mind and high volume production in mind. And we're trying to harness all the cost and time savings that comes through using those components. And so that's what we're trying to assemble on QuickSounder. We're trying to demonstrate that we can fly this weather instrument using an assembly of spacecraft components developed by the commercial space marketplace.
The benefit to NASA and NOAA for a reduced schedule is the ability to infuse new technology much more frequently than they currently can. With their current development cycles of 10 years or even longer once you include the instruments, which have to go through a separate design cycle that traditionally has been quite long. By the time a spacecraft like JPSS is launched, the technology is at least 10 years old, if not 15 years old or older. So that's why NOAA is trying to go in this new scenario where they can launch more frequently and more rapidly to get current technology up and benefit all of us in improving the weather forecast.
QuickSounder will bridge a gap in weather data near dawn and dusk at 5:30 a.m. and 5:30 p.m. That satellite data informs NOAA weather models that provide our daily forecasts. Our city, San Antonio, Texas, is sweltering in the summer, so it's an ideal spot to study urban heat islands, or UHIs, which occur when dense concentrations of pavement and buildings replace green spaces, causing temperatures to soar. On episode 70 in August, engineers Shane Siebenhaler and Justin Long told us about SwRI's data fusion tool to identify areas that most need relief from the scorching summer heat. All right, so many good solutions there. I love that. Plants, water features, those reflective materials. And I really liked what you said about urban planning, starting thinking about UHIs and the concept of cooling things down at the design phase. So I think that's really important. So tell us about your comprehensive data analysis tool. How does it work? What type of data is it collecting?
So from the user perspective, what you see is a map of San Antonio with zooming and panning capabilities, with a window that has several drop-down menus in which the user can choose what data is being shown on the map. So a feature of the tool is that it enables the user to layer specific metrics of interest on top of each other. And then you can filter and tune and kind of dial the knobs so that the map only shows areas that match those criteria of interest. So for example, if you want to identify census tracts that have household incomes less than $50,000 per year, let's say, and have heat vulnerability scores of 5 out of 5, with 5 being the worst, you could set those thresholds and the map would only show the tracts that meet those criteria.
So the tool uses over 230 different data sets, and the beauty of it is that you can draw correlations between multiple different parameters. So as an example, one of the case studies we used with the city was looking at bus stops. And so if you have a certain amount of money to install shade structures at bus stops, where do you put them? And so what we did is looked at where do you have the highest temperature? So where do you have these urban heat islands? Where do you have high ridership in areas of low income where you're most likely to have people needing to take public transportation to work? And where you don't have some nearby tree or other shade structure. And so what it allows you to do is take multiple different parameters and then end up with sorting to give you candidates for any time that you have limited resources.
Looking ahead, the UHI data fusion tool may be used to evaluate air quality to determine what populations are at risk for respiratory issues. Next stop, Europa. In September, on episode 71, SwRI Space Sector Senior Vice President Dr. Jim Birch and space scientist Dr. Kurt Rutherford told us about the 2 SwRI instruments aboard NASA's Europa Clipper spacecraft heading to Jupiter's icy moon. They explained the mission is exploring Europa in search of the ingredients for life. The Europa Clipper launch window opens October 10th, so we want to hear about how you're preparing for the big day. But let's start with an overview of NASA's Europa Clipper mission. What is the purpose or goal of the mission?
Overall, we're looking to learn more about Europa's habitability. That's a loaded word to not say that we're going to go search for life, but that's really what we are hoping to do eventually in space exploration. But what this means is, does it have the ingredients for life? Does it have water? We're pretty sure it has a liquid water ocean. Does it have stuff for bugs or people to eat, basically, the raw elements? And then is there the energy to keep those materials coming to sustain life in this environment? And that's what habitability means.
Can you tell us about this ocean, this vast ocean that scientists believe lies beneath the surface?
Yeah, this ocean was detected on a previous mission, Galileo, by magnetic field measurements. And Europa Clipper will also make magnetic field measurements to confirm and learn more about this ocean. It gives magnetic signals because there's salinity in this water, like salt water, as you said. And as the planet rotates, there are eddy currents that build up, and these create magnetic fields. So we know there's an ocean subsurface. The question is, can it support life? And so there are various different instruments. There are imagers that look in various wavelengths, ultraviolet, like Kurt, is infrared, visible. There's a dust detector. There's a radar that probes the structure of the moon. And then there's mass specs, which looks for organic compounds. And as Kurt said, you also have to have a source of energy. It can't be sunlight like on Earth because the moon is under the surface. It has to be chemical energy from chemical reactions. So mass specs also looks for products of those chemical reactions.
Europa Clipper launched October 14th, 2024. The spacecraft is traveling 1.8 billion miles to reach Jupiter in April 2030. It will orbit Jupiter and conduct 49 close flybys of Europa. Marching toward the end of 2024, October's episode 72 featured SwRI Executive Vice President and COO Walt Downing. Downing told us about the Institute's internal research and development program, which supports future-minded SwRI scientists and engineers exploring unproven ideas or concepts. So this is really, as we mentioned, a forward-looking program. You're kind of looking into the future and trying to guess or think about what is going to be big further down the road. So how does that work? How, your scientists and engineers are coming to you with these, again, unproven concepts, but it really is part of the forward-looking process, looking into a crystal ball.
Well, again, it's a twofold type thing. One is you have to be connected on the research side, the basic research side. That's where it's important to participate in professional societies or conferences where new technologies are published and discussed and presented. So you have to be aware of that. And then on the client end, you have to be well connected to know where they're going, what their needs are. And it occurs in a variety of ways. Like in many of our government-related programs, our clients often put together roadmaps of where they need to go. And that allows us to see and then think about the technologies that might help them get there. On the other hand, some of our work's regulatory driven, like particularly our automotive areas where you're looking at emissions reductions or fuel economy improvement. And our regulatory agencies provide us clear guidelines of where our customers are going to need to be in the future. And there's many different technology paths that you can take to get there. And so those are the sorts of things that give us an idea or an indication of what we need to be looking at, and those are things that make the ideas arise for the internal research projects.
Visit ird.swri.org to learn more about SwRI's IR&D program and the projects funded since 2018. To close out the year, we tackled traumatic brain injury, or TBI, which occurs when an outside force causes a head injury that affects brain function or results in disability or death. Senior research engineer Craig Zimmern and research engineer Dr. Daniel Portillo told us about 2 cutting-edge solutions targeting TBI. So, everyday activities can cause a TBI, a fall, a car accident, playing sports. So this really is a topic that can affect anyone, everybody, anywhere. So let's talk about the solutions under development at SwRI right now. Craig, let's start with you. Tell us about SwRI's new screening tool for TBI, the Advanced Military Measure of Olfaction, or AMO. What is it? How does it work? Who can use it?
So olfaction is smell. So olfaction is being able to sense and describe smell. And so the AMO kit is a medical device that we've designed to identify smell loss or anosmia, the inability to identify correctly identify smells. And so there's lots of early evidence that shows it could be a very useful screen for traumatic brain injury. This isn't a diagnostic by any means. This is a tool that can be used to look for an objective data point.
SwRI and the University of Texas at San Antonio are developing these military helmet pads designed to prevent TBI. So tell us about the specialized padding. What's it made of? How does it work?
So the military environment is a little bit different than, say, a football environment where they still wear helmets. A football environment, you would expect to see a lot of what we call blunt impacts. And those are impacts where guys are hitting their heads together, maybe falling on the ground. You expect to see those in the military world too, right? Somebody falls, runs into a wall, something like that. But there are also ballistic and blast threats that military personnel are exposed to that we would not expect, hopefully, a football player, right, to be exposed to. And so we started to ask ourselves, okay, these pads that are in there, we know that there are existing materials and technologies to manufacture really unique structures now that may not have been available, a decade, 2 decades ago. So can we try to leverage the new materials that have come out, the new manufacturing technologies that have come out, and try to improve the existing military helmet pads?
Other TBI and brain health projects are underway at SwRI, including exploring machine learning for diagnosis and prognosis. On this particular episode, it was great to hear our 2 researchers learning about each other's projects in real time. You can catch the entire conversation on episode 73. Whether it was vehicle cybersecurity, that rare total eclipse the Europa Clipper launched to Jupiter's icy moon, or another topic, I hope you found inspiration and learned something new as you listened to the podcast in 2024. Stay tuned for more tech talk in the new year. If you've missed past episodes, you can go back and listen at any time. You'll find all Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, X, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SwRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Peña, wishing you a happy 2025. Thanks for listening.